You are welcome to today's class. Today we want to continue from where we stopped from projectile. If you have not watched the previous video teachings that we did concerning projectile, I will encourage you to go to our videos and watch it because this is the second aspect of projectile. Today we want to consider horizontal projection. What is the meaning of horizontal projection? Horizontal projection simply means when an object is projected horizontally with horizontal velocity u from a particular height as shown below. So this is the meaning of horizontal projection. When we have a particular height like this, let me redraw. Let me just redraw. When we have horizontal projection, yes, the object is being projected from a particular height. Let's say this is where the object is being projected from. So this is our vertical height and is being denoted with h. So it's being projected horizontally with initial velocity u, initial velocity u, yes, and the object, you will agree with me that the object will move horizontally like this before coming to this particular point, and the horizontal distance covered is this one. So I denote this to be what? To be r, which means horizontal distance of this projectile, Okay, from there, how do we get the relationship between this height, this u, and this horizontal distance? You will agree with me that from here to this particular point, there will be a particular time that will be taken. So from there, we make use of our equation of motion. One of our equation of motion, yes, one of the equation of motion that says S equals ut plus half at squared. But this time around, we are dealing with vertical distance. So definitely our S will turn to h equals to ut plus half this a. This acceleration will now turn to acceleration due to gravity. So from there, we can go ahead and say this h equals to ut plus half gt square, and you will know that this is positive because the object is actually coming in the direction of force of gravity. Yes, the object is traveling in line with gravity, so to say. So from there, we will now sense that our h will now equals to, okay, from there I can say that when we are dealing with this vertical height, at this particular point, the vertical component of this initial velocity u is uy, which is equals to 0. Don't forget that the object is being projected horizontally. So the horizontal velocity is this u, while the vertical component of this u, which is uy, will now equals to 0. And you will still agree with me that when we are dealing with vertical height, it is this uy that we are going to take into consideration because it's the vertical component of this initial velocity u that will be keeping the object to move downward. So from there, we have discovered that our uy is 0, therefore our h will now be 0 times t plus half gt squared. So from there, we can sense that our h, this will give us 0, so we have 0 plus half gt squared. Definitely it will now be half gt squared. So as horizontal projection is concerned, this h equals to half gt squared. So that's the relationship between h, this is the relationship between h and the acceleration due to gravity plus the t, the time taken from this particular point to this particular point. So from there, let's proceed. Again, what will now be the relationship between this u, this u and this horizontal distance covered? That's what we want to examine. So again, we are still making use of S equals to ut plus half gt squared, which is our equation of motion. But since we are dealing with the horizontal distance covered, so our S, which is distance covered, horizontal distance covered here, will now be R equals to ux, yes, uxt plus half gt square. I call it ux simply because from here, this is our ux, so to say ux is this because is the horizontal distance in the direction of x, the horizontal direction. So it shows that the initial velocity in which we use to project the object is our ux. So from there, we can now say our r equals ux t, that is the time taken from this particular point to this particular point. So from there, we can now say plus, but I want you to remember that when we are dealing with horizontal projection, acceleration due to gravity, or let me say gravity, has no influence. So from there, we can say half equals to 0 multiplied by t squared. Here, we know that g equals 0, or let me put it this way. Yes, I can summarize it like this, that for for horizontal motion, yes, gravity is 0, that is it has no influence on the horizontal motion. So we can simply say our r equals ux t. So from there, we should take note that this is the relationship between our horizontal distance covered from this diagram and then equals to ux, which our ux is the initial velocity of projection, yes. And then you should know that our t, we should take note that our t is the time taken, our g is acceleration due to gravity. Okay, and what is our r again? We should not forget that is our horizontal distance, covered, where our h, yes, I'm trying to define all our parameters now, which is h equals to the vertical distance. So that shows that in this aspect of projection, horizontal projection, so to say, so we have the summary. Our summary will now be, yes, what is our summary? R is equals to ut, and then our h is equals to half gt squared. So these two relationships are very, very important when we are dealing with horizontal projection. So we want to go to example now. A stone is thrown horizontally with a velocity of 15 meters per second from a height 100 meters. Calculate the time taken to reach the ground, the horizontal distance of the stone when reach the ground, the velocity at which the stone hits the ground. We are given g, which is acceleration due to gravity 10 meters per second. So let's bring out all our given parameters. Yes, we are given, yes, initial velocity, which is u equals 15 meters per second, and we are given our height. Our height is h, which is 100 meters, and we are asked to calculate the time taken, which is our t. Our time taken is our t. We don't need to forget that, yes, is unknown. And then how do we go about this calculation? You are going to recall, yes, you recall the summary from here. You will agree with me that the r is equals to our r equals ut, and our h equals to half gt squared. So from this, we are given u, we are given h. We are asked to calculate time. So from here, can we make use of this formula in order for us to calculate our time? You will agree with me that, yes, this one, h equals half gt squared. So we are given our g to be 10 meters per second squared times our T is our unknown. Our T is unknown. So our H is being given to us as 100 meter. So from there I can say this is 5t squared. So from there I can divide both side by 5. We divide both side by 5 and this one will give me 1. Therefore, yes, 100, 5 in 100. So you will agree with me that 5 here 1, 5 in 100 is 20. So my t squared is equals to 20. Therefore, I can simply say my t is now square root of 20 seconds. Square root of 20, and then this t will now be, you will agree with mathematically now, 4 times 5, which is 2 root 5 seconds, in case our answer is in third form. So how do we calculate the horizontal distance covered now? So you will now recall the same way, R equals to UT. Our U, don't forget that our U given to us is what? Is 15. So our U, that is the initial velocity given to us, is 15 multiplied by 2 root 5, which is our time that we have just calculated. So this one will now give us 2 times 15 will give me 30 root 5 meter. 30 root 5 meter. And then the last question given to us, we are asked to calculate the velocity at which the stone hits the ground. So here, which is, I'm dealing with number 3 question now. Yes, you will recall that, yes, from our equation of motion, we have v squared equals u squared plus 2gh. You will see that when we are asked to calculate the final velocity at which the object hits the ground, we can make use of this equation of motion, because all the parameters except this final velocity are available. So we can simply say 15 raised to power 2. Yes, the object is coming down, so our g will attract positive sign, multiply by 10. 2 times 10 multiplied by 100. So from there, I will have 15 raised to power 2 plus 2 times 10, which is 20. 20 times 100. We now have 2000. Yes, my answer now will be 2000. So 2000 plus 15 squared will now give me 15 raised to power 2. 15 raised to power 2 will definitely give me 15 times 15. So that's how to get it. You just multiply 15 by 15 in order to give you 225 plus 2000. 225 plus 2000 will now give us 2220, 2225, and then so our v square now is giving us 2225. So my v my v will now be square root of 2225. So what will now be the square root of 2225. So by the time you press your calculator, you are going to get your answer. So that's the end of this class today. Thank you so much. If you have not subscribed to this channel, kindly subscribe. Go to YouTube now through this link and subscribe to our channel. Thank you.